Okay, good evening, everybody. Kind of in a hurry tonight, so I'm going to try and rush through these, which I'm sure several of you will be very appreciative of if I can shorten this down. But anyways, what I mean by that is it's very possible you will catch some mistakes because I'm going to be writing and thinking at the same time here. So of course, be patient. Hopefully, I'll catch my own mistakes. All right, here we go. So we're going to be talking about solving absolute inequalities. And like I mentioned in class the other day, that I do not believe I'm going to teach you anything new today. I think what we're going to do today is we're going to apply stuff that we already know. So one thing that hopefully we know at this point, which I am seeing probably 80% or so do as a habit, but not 100%, and I would like it to be 100%. And so make sure, here's a good fifth color. Every single time, I want you to do this as your first step. Equals 13. Every single time. Okay, I know you think, oh, I don't have to. Whatever. Please do. You will just make this stuff much easier, much less likely to make a mistake. And you never know, once in a while, I give some bonus points for people to do stuff that I like. Okay, so there we go. I've made my first step. Now, it's an absolute value. We've been solving absolute values the last couple of days. In fact, you guys are doing quite well at it. We split it up into two parts, just like this. I would suggest that you organize your paper the same as I am. I see some people kind of doing it top and bottom. I would do it left and right. So you're solving these things simultaneously next to each other. And remember that the only difference between the two problems, the only change that you make when you're doing this is you change one of your answers to a negative instead of a positive. So I changed the right-hand one into negative 13 instead of positive 13. And now I go ahead and solve. So I'm going to add 3 to both sides. I get 2x is equal to 16. Divide both sides by 2. X is equal to 8. Now, I'm seeing a few people, 5, 6 people, not a whole bunch, who are not actually splitting up into two different problems. They're doing this right here, like I did, to get x equals 8, and then they write this down. Please do not write this down, but pay attention. They write this down, and x equals negative 8. That is not true. You cannot guarantee that the other answer is going to be the opposite of this one. Okay, so we do solve for this one. We don't then say, okay, it's also equal to negative 8. Remember, this is not starting at 0. Whenever I have plus or minus on the inside of my absolute value, I'm no longer starting at 0 on my number line. Therefore, this is a false answer. So please don't do that. Instead, what I would like for you to do is, erase that. I can't erase it, so let me do it like this. Sorry about that. I got to do this the old way, which is to scratch it on out. Okay, so what I would like you to do instead is to solve the right-hand side as well. So add 3 to both sides, add 3 to both sides. 2x equals negative 10. Divide both sides by 2. So x is equal to negative 5. All right? So, yeah, you'll notice these two are not the same answer. Whoops, didn't mean to do that. These two are not the same answer. Uh-oh. Nightmare. Okay. So what I just found is my dividing point. So I draw my number line like this. Here I put 0. On the left side of my dividing point, I put negative 5. On the right side of my dividing point, I put positive 8. And now what I need to do is test a point. So the point I'm going to test is going to be somewhere in between my two numbers. So somewhere in here, it looks like 0 is a good number to test. I want to make sure that when you test it, you come back to the original inequality. So you have absolute value of 2 times 0 minus 3, absolute value is greater than or equal to 13. So in here I have negative 3, absolute value is greater or equal to than 13. So 3 is greater than or equal to 13, and that is false, which means this is false, which means, oh, I forgot to do my dots and donuts. So above my number line, or excuse me, above my dividing point, I should put in a dot, and above this dividing point, I should put in a dot. And then that means that the arrows go away from my sign. And if I've done those two things, then I can write my answer. Underneath my line, I write x. On my dividing point, I write my dividing point. And if I do that, I always use the less than symbol. In this case, it's less than or equal to. So here is my 8, there is my x, and less than or equal to. So this is the answer right here. Everything else is the work that gets me to the answer. Okay, take a look at the again, same type problem, just done a little bit more work to do. So we're going to do the same first step, which is 5 times the absolute value x minus 7, absolute value plus 2 is equal to 12. Now, when we do this one, we want to make sure that we get the absolute value by itself first. So I'm going to get rid of this 2 here. And on the left-hand side, I have 5 times the absolute value equals 10. Notice that I don't need to write the absolute value in there because I'm not worried about it until it gets all the way by itself. So it's a little bit of time savings. The next thing I'm going to do is divide this side by 5. There was some confusion yesterday in a couple of the classes about why I'm not dividing what's inside my absolute value. When I divide by 5, all that's doing is simplifying out with that. And this becomes a 1 and that becomes 1. Now I have 1 times my absolute value, which of course is just equal to my absolute value, equal to 2. And now what I notice is that this is a positive number, so I should be okay there. So I can go back and put in my x minus 7 and divide into 2 different things here. X minus 7 equals 2, and x minus 7 equals negative 2. Then I'm going to add 7 to both sides, and I get x is equal to 9. Add 7 to both sides, and get x is equal to 5. What I've just found is my dividing point. So now I can plot my point. So I plot it like that. And I put my 0 in, and to the right is 5, and to the right of that is 9. Now I'm going to go back and plot my dots or donuts, and I come up here, and I see that this should be a donut. Seem to be doing a pretty good job of dots and donuts now. And next I need to test a point, and I'm going to choose a point that's in between these two, so I'm not going to pick 0 this time, pick a point in between these two. So if I pick let's say I pick the number 6, whatever. So I come up here, and I plug it back into my original inequality. 5 absolute value, 6 minus 7 absolute value is not awesome. Let me erase that. Okay, try that again. So I have, whoa, that's weird. Undo that one. Why? Undo doesn't seem to be working today. I'm sorry about that, everybody. Okay, so what I have is 5 absolute value, 6 minus 7 absolute value, plus 2 is less than 12. So now I'm going to solve this. So I have 5 absolute value, negative 1, absolute value plus 2, less than 12. So I have 5 times 1 plus 2 is less than 12. 5 times 1 is 5, plus 2 is less than 12. Again, I know it's kind of hard to see in here, but hopefully you're listening to me. So 7 is less than 12, which means that that is true, which means this is true, which means my line goes like this. And that means that for my final answer, I can say under my dividing point I put 5, under the line I put x, and if I do those two things, I always use the less than symbol, and under this dividing point I have 9, there's the less than symbol, so my final answer is 5 is less than x, and x is less than 9. So that's my final answer. Okay, so those are the notes for today. Excuse me. You'll see, I don't believe there was anything new. All we did was we applied together the absolute value idea and the inequality idea to come up with one answer. So the answer there for this one is 5 is less than x is less than 9. Okay, I'll see you guys tomorrow, and we'll do lots of practice with this stuff. Have a nice night. Goodbye. Go Cardinals.